Welcome all to the Analog lecture series. So in this session we are going to learn one more thing, something new. So this is the given circuit. If you observe in this circuit, we have to calculate the value of input impedance and also we have to calculate the value of output impedance. But the thing is, we are requested to calculate our expression in terms of hybrid model parameters. You know, I have been given three types of models. We know how to redraw the transistor while doing AC analysis. Either we can go up with the pi model, or we can go up with the RE model, or we can go up with the hybrid model. Whereas here it is specifically mentioned that we have to write down the AC equivalent parameter, that is input impedance and output impedance, with the help of hybrid model only. That is the given question, right? Shall we start analyzing the question? Let us take the question. First of all, while applying AC analysis, we know what to do. We have to deactivate all DC sources. Now if you observe the circuit carefully, we are having DC sources at two places. One is the value of VCC, another one is the value of minus VEE. So step number 1, while doing AC analysis, we have to deactivate all DC sources. How will you deactivate? If it is the voltage source, then we have to short circuit. If it is the current source, then we have to open circuit. Anyway, these both are voltage source, so I am deactivating by short circuiting them. So directly I am connecting it with a ground. After that, let's start drawing the equivalent circuit of transistor. So we have to start from input supply, that is AC input voltage. After that, there is one resistor is given, that is RS, that is the source resistance. RS indicates source resistance. After that, it's time to, we have to explore or replace the transistor by its equivalent AC model. But as I told you that we have to express it in terms of hybrid model. How will you express it in hybrid? It can be written as HIE. Here it is going to be emitter terminal. Here we have to connect our current source, and the current source can be written as HFE into base current IB. Okay sir. After that, yes, this is going to be your collector terminal. Now if you observe the emitter terminal is connected with one resistor is called RL, and that will be connected with the ground. So I am calling it as RL. After that, collector terminal is directly connected with the ground. So just I am expanding it and I am just simply connecting it with the ground. That's all. So that is the AC equivalent circuit. Now from this, I would like to tell you few more things. Carefully observe. Whenever you are calculating simply input impedance, there are two type of input impedance. One is total input impedance that we are observing from the source, total input impedance, and another one is simply input impedance. Sir, what is the difference between total input impedance and simply input impedance? Total input impedance in the sense you have to observe the overall impedance offered by the circuit from the source voltage. If they are simply asking you to calculate the input impedance, then you have to neglect the resistance offered by the source. You have to calculate the rest of input impedance. Are you getting me? So the difference between total input impedance from the source, in the sense we have to consider the source resistance also. But when you are considering the effect of only input impedance, in that case you no need to consider the effect of source resistance. Simply consider the value of input voltage from here, and you know transistor will be consuming a current is called base current IB, and from this side we are having collector current IC. Of course, from this terminal only we are going to measure the value of output voltage V0. It was clearly given in the question, you can observe it. See there? Yes sir. So I hope you all understood what I am trying to conclude here. That's all. Now in our question, simply we are requested to calculate the input impedance. Yes. So let us see what we are going to do here. If I will observe, see, if you all observe here, current entering point plus leaving point is minus. After that, through this, what is happening? Base current IB is coming here, whereas here HFE into IB is coming. So if I will apply KCL at this node, what you will be getting? So the overall current HFE into IB plus base current, one more base current is coming. So the overall value can be written as HFE plus 1 into base current IB, that is the overall current that is entering into the emitter terminal. Now for the emitter terminal, current entering point plus leaving point is minus. The load resistance is given across the emitter terminal, that is RL. Now what is the voltage drop across the load resistance? Voltage drop can be written as current IB into 1 plus HFE into load resistance RL, that is the voltage drop. Now if you simply apply KVL for this loop, then you will be getting the overall not total input impedance, just input impedance. I told you the difference between them. So just if they are asking you to calculate the value of input impedance, then neglect the effect of source resistance, simply calculate the remaining input impedance, that is nothing but the ratio between input voltage and input current IN. Of course input current IN is nothing but our base current IB. For that, when the moment, this is going to be our input impedance, when the moment you are applying KVL, what you will be obtaining? Let me start, minus Vn. Just observe, I told you don't consider the effect of source resistance, just start from here, minus Vn and then plus HIE into IB, the voltage drop across the value of HIE into IB. If you multiply the resistance with the base current, you will be getting voltage drop. After that, the voltage drop across the load resistance RL is RL into 1 plus HFE into base current IB will be equal to 0. Now if you observe from this expression, you can keep minus V in one side, you can pass rest of these two terms to the right hand side, such that overall it will become minus of, take base current IB outside, then it will become HIE plus RL into 1 plus HFE. That's all. Now further what you can do is simply minus minus will get cancelled, pass this base current to the left hand side, such that the value of input impedance, actually they are defining it as Z in, right? 1 minute. So let me take Z in. So the overall input impedance Z in equal to input voltage V in upon base current IB. Of course this will be equal to HIE in surplus RL into 1 plus HFE. That's all. I hope you all understood this. Suppose in the same question, if you are requested to calculate the overall input impedance, then what you must do? Just consider the value of RS also. Start from the KVL from here, then it will become minus Vn plus IB into RS and then plus IB into HIE. Further, that's all. So what will be resultant will become just the overall value will be added with the resistance RS also when we are considering overall input impedance. Whereas here just we are calculating the input impedance offered by the transistor. So input impedance offered by the transistor means you need not to consider the effect of source resistance. That is what I would like to conclude. Here the question is, what is the overall input impedance offered by the transistor? Simply Zn means that is the input impedance offered by the transistor. Okay, fine sir. Now there will be one more question, right? We have to estimate the value of output impedance also. I have already told you the procedure to calculate the value of output impedance. See, whenever you are estimating the value of output impedance, first identify the load terminal. Just apply Thevenin theorem. Identify the load terminal, remove the load resistance from the load terminal, then connect the external voltage source VDC and assume that VDC is supplying the current of IDC. Then try to bring the relation between VDC and IDC. Meanwhile, while applying Thevenin theorem, we have to deactivate all independent sources. So if you find any independent sources, voltage source or current source, whatever, try to deactivate them. After that, apply nodal, KVL, whatever that you want to do. Bring the relation between VDC and IDC. That will give you the value of output impedance. Okay, this is how we are calculating the output impedance. This conclusion we know. So just apply this procedure and bring the value of output impedance. So in the next lecture, if you find the answer, try to drop your answer in the comment section. Otherwise, in the next lecture, I will be dropping the answer for this question. This is all for this lecture. Remaining things we will see in the next class. Thank you all.